Alright, so today we're going to look at drawing out covalent molecules that are ions. We're going to figure out how to draw those polyatomic ions. So starting off, let's look at my favorite one because it's the most biological use. That's phosphate, PO4 with charge -3. Alright, so just how we did breaking the octet rule, just how we did following the octet rule, let's just start off by drawing what this kind of looks like. Phosphorus is there. 5 outer shell electrons. Typically it's going to want 3 bonds up until we break that rule. So we have 4 oxygens down here. Each of them has 6 electrons, want 2 bonds. Chances are some of them might be able to do that. Alright, so now we're going to already see some big issues here. Phosphorus only has 5 electrons, and the oxygens altogether are going to want 8. So let's go ahead. Let's do single bonds between the oxygens and the phosphorus. Let's do that, and then this oxygen on the end wants 2 bonds. Phosphorus still has 2 electrons to give, so let's just go ahead and do that right off the bat. Alright, I know I'm not done. I'm going to draw it pretty. Draw it nice and neat right now. Phosphorus, 2 bonds to 1 oxygen, which has 2 pairs of electrons. And we've got single bonds to these oxygens. Something like that right now. Alright, now, in order to make those 3 oxygens there have full outer shells, that's where this -3 comes into play. The -3 tells us that there are 3 electrons that have come in from somewhere. It doesn't matter where, it just could have been a passing metal. The big thing though is PO4 has these 3 electrons to deal with. Now those 3 electrons are going to pair up with lone electrons. So let's go ahead and redraw these 3 things here as just lone electrons. Alright, so now those 3 electrons are going to pair up there. Now, when we put an electron on, say, that oxygen right there, it's going to make that oxygen negative. Put a second electron there, and the third one's going to go right there. Alright. Now remember, when you gain an electron, you become negatively charged. And so those 3 oxygens there each have a charge of -1. All together, I have 3 negatives, and if I look back at the original formula, I've got a charge of -3 here. So that shows that I at least did this part right. Let's go through. Let's do one more. There we go. So let's look at NO3. Charge of -1, NO3 minus. So let's get our nitrogen, 5 electrons, 3 oxygens, each of them 6 electrons. Typically want 2 bonds, but so we're working with polyatomic ion. That's probably not going to be the case. The other way you can do this is you can just kind of put those extra electrons on one of the. We have 1 extra electron here, so let's go ahead and put it on one of the oxygens. Put it there. Give it a negative charge. All right. So you know that oxygen only wants 1 bond, so let's just go ahead and be done with it. So now we have this oxygen here, 2 bonds. Let's just give it the 2 bonds nitrogen has. And so we have 1 oxygen left, wants 2 bonds. Nitrogen has 2 electrons to give away, so let's go ahead and do that. All right, hard part's done. We figured out what goes where and where the electron's going. So let's draw this nice and neat. Nitrogen in the middle. 2 bonds to an oxygen with 2 pairs of electrons. 2 bonds to that oxygen, just 2 pairs of electrons. And we have 1 bond going to the oxygen that has 3 pairs of electrons, and more importantly, that negative charge there. Now, it doesn't matter which of those 3 oxygens you give the extra electron to, which one's are double bonded, so long as the one you give the electron to is only singly bonded to that central nitrogen. So that's drawing ions. It's not too much different than breaking the octet rule, but it can be a little bit tricky. All right, so with that, go ahead and finish up those last 2 pages of the work packet, and we'll call it good. We'll start with shapes and electronegativity negativities the next 2 class periods.